Welcome, my Algebra 2 students. We are in lesson 36. If you hear some crunching in the background, my dog Roscoe has found him a bone, so he is making the most of it and crunching all over it and slobbering in the process. So we'll ignore him and continue with our lesson. We're going to talk about some multiplication and division of rational expressions. Now, a while back, we talked about turning trinomials into two binomials through factoring. So let's just jump in to example 36.1. We're going to show you now why that is important and how you can apply it. So let me write down this problem for you, and if you'll write as I write, we can save a few minutes, and I'll try not to read it out to you as I write it down, which I want to do sometimes. And that is going to be times, so we use the little circle, we are just about to the point in which we are learning completely new material. So far in Algebra 2, we have been taking what we learned last year and just digging a little bit deeper into it. Pretty soon we're going to be in completely new territory. And this is about the outer edge, the upper limits of that. So this is where factoring really comes in handy. I really have no desire to multiply these each, because if I did that, I'd have 3 of these and 3 of these and 3 of these. That'd be 9 on the top and 9 on the bottom. Man, that's a lot to wrap your head around. There's an easier way. We can reduce before we do any kind of multiplication. But we're going to reduce by factoring. So let's factor the top and the bottom of each one of these before we start doing any kind of multiplication, so we can see if there's hopefully something that we can factor out, right? So here we go. Here's our sets of parentheses. A set for this side and a set for this side. So let's factor out x squared plus x minus 12. We know that we got x's in the front. We have x's in the front of all of these, so we can just go ahead and fill those in. That's pretty straightforward. So that takes care of all of our x squares. All right, so now we have a negative 12, and we have to have a positive 1 left behind. So that tells me we're going to have a positive 4 and a negative 3, because a positive and a negative is going to be a negative, but positive 4 minus 3 is going to be a positive 1 remaining. So that's that one. Now we have a negative 20 and a negative 1x. So that tells me we're going to have negative 5 and positive 4, because the two together make negative 20. And when we combine them, we get a negative 1. All right, let's do, we have a 2x left. We have negative 35 and a positive 2. So it tells me that the 7 is going to be positive and the 5 is negative, because it's negative 35, and when they're combined, we have a positive 2 left over. And here we have a positive 14 and a positive 9. That tells me we have positive 2 and a positive 7, because the two together combined give us a positive 9x. And if you do not remember or are having a hard time following along with the factoring of these trinomials into binomials, please message me so that I can send you a support video that explains that process. I don't want this video to take an hour or two. So I would rather move on to the new material, where what we're using this for, and I can send you another video that will explain this and how I'm doing what I'm doing. Okay, so we're to this point now where we have factored the tops and bottoms of each fraction. Now we know that these are multiplied by these, and these are multiplied by these, and since this is a multiplication symbol, all four of these could go on the same line, and all four across the bottom could go on the same line. They're all factors at this point. Now we just need to see if there's something we can get rid of. So I see here we have an x plus 4 and an x plus 4. Top and bottom goes away. And we have an x plus 7 and an x plus 7. Top and bottom, one on the top, one on the bottom goes away. Excuse me. I also see we have an x minus 5 and an x minus 5. It doesn't matter that they are in different fractions because they're being multiplied by each other. So we can get rid of them because they're going to be factors to each other. So what we have left is x minus 3 over x plus 2. Isn't that easier than doing all of that multiplication? Yes. Okay, so that's what we want to do from now on with these types of problems, is we want to factor them out so that we are not stuck with this long multiplication process. We can just eliminate and be done with it. So let's do 36.2. I'm going to write it up here for you, and then I want you to try to solve it yourself first. Sorry, mouth is dry, and I've been doing a lot of videos today, and so I've got a little bit of a cough from just talking too much. If you'll write this down as I write it, y'all know the drill by now. That way we are done at the same time, and you don't miss something I say that might actually be important later. All right, so here is a division problem. Now remember, keep it, change it, flip it. Factor it first, then do keep it, change it, flip it. Then see if you can eliminate something after you flip the top to the bottom and the bottom to the top. All right, so I am going to let you pause the video now and solve the problem. All right, so I didn't finish mine completely. I got it factored out though. And when I factored it, I went ahead and I wrote it as if I were multiplying. And when I factored the top, I wrote it in the bottom to save myself a step. And when I factored the bottom, I wrote it in the top. So I flipped it as I factored it, if that makes sense. For the sake of saving a step on my paper, because this takes up a lot of room. So now I'm going to cancel, and I can cancel this and this. I can cancel this and this. And I can cancel this and this. And I'm left with x minus 2 over x plus 3. And if you got x minus 2 over x plus 3, then you did it correctly. Congratulations. We have one more to do. So let me clear the page, and we can do that one together just to kind of go over it one more time. So here we go. I'm going to write 36.3 really quickly. Watch. Do you see how fast I wrote that? I bet you didn't even watch me. But you couldn't even see my pencil move. Okay, so I paused the video. Anyway, let's go ahead and look at these. Now, I want you to notice that, first of all, these are not all in that trinomial second degree format that we're used to. So that what that means is we're not going to factor all of these the same way. We're going to do some different factoring for each one of these. Now, the first one right here, we are going to factor because it's the same as we're used to. We have an x squared, so we put an x in the beginning because x times x is x squared. Now we have a negative 6 that needs to end up with a positive 1. So it tells me that the 3 is going to be positive and the 2 is going to be negative, because a positive 3 times a negative 2 is a negative 6. But when you combine positive 3 and negative 2, you get 1x left behind. All right, so that's factored. All right, now on the bottom, we can't factor that like normal. We have to take an x out of everything, right? Because we have too many things here. We are going to factor it as a binomial, but we're just going to take x out of it. So what that leaves behind, when we do that, I'm going to write it over here to the side. That's going to leave an x, and we're going to have x taken out, and that's going to leave x squared minus 2x minus 35. So you see where I'm going with that? And then that becomes, we just put the x there. So that's x and that's x. And now negative 35 with a negative 2 remaining, that means that the 7 has to be negative and the 5 is going to be positive. Okay? All right, so now I'm going to go ahead and change this to multiplication, and I'm going to go ahead and flip it. This can't be factored at all, so we're just going to write x plus 3 down here. And I'll just put parentheses around it just to make it look like everything else. And then this, we can only factor it one way, and that's x minus 7, just like that, right? So those are our factors for this. So everything is multiplied against everything, so we can factor it out as we want to. I'm going to switch to this red just for the fun of it. So we have an x here, and we have an x here. We have x plus 3 here, and we have an x plus 3 here. We have an x minus 7 here, and an x minus 7 here. So what that does is that leaves us with x minus 2 over x plus 5. And that is the answer to our problem. And you can see, if you just think about the problem that you have and the types of numbers that you have, and you put a little bit of planning and forethought into how you factor and how you set up the problem, it could be fairly easy. You just have to think about what you want to do before you do it. All right, and that is all that we have for lesson 36. And I hope you enjoyed it. It's actually starting to get to be a little bit more fun now. At least it's fun for me. I hope that you guys like it too. And I'll see you guys in lesson 37.